Hello and welcome to this video on Are you cheating when you impute missing values? My name is Geiser. I'm an instructor and statistical consultant with QuantFish, and on this channel I present weekly statistics tutorials, usually related to multivariate statistical methods such as structural equation models, factor analysis, multi-level analysis, and latent class modeling. If this is something that interests you, then please subscribe to this channel. Also, don't forget to hit the like button and to check out the description for additional resources, including a link to my free weekly statistics newsletter, as well as links to courses that I offer through QuantFish. One issue that we often have with multivariate statistics, but also with simpler statistical methods such as regression analysis, correlation analysis, analysis of variance, is missing data. And so missing data are very common in cross-sectional studies and also in longitudinal studies. Some people don't respond to certain items for whatever reason. They may randomly overlook an item. They may feel uncomfortable responding to certain items. They may not know what to respond to certain items. Or in longitudinal studies, they may drop out due to them moving away or being sick on a given measurement occasion or other reasons, or you might lose data. Data may be incorrectly entered into your database and then may have to be removed later on because you don't know what the actual true or actual valid score was. And so there are a variety of reasons why you may have missing values, and there's almost no study in the social sciences that is completely free of missing values and has entirely complete cases. And so this is something that can be a concern, especially when you have a lot of missing values, and then you may ask yourself, what should I do with the incomplete cases? And that makes many people uncomfortable. Many people resort to methods such as listwise deletion of cases with missing scores or pairwise deletion, and they don't use methods, or they don't feel comfortable using methods where they impute the missing scores with estimated values. And so there's some good reasons why people feel uncomfortable about this, because we're being taught you should not fabricate data. Of course, you cannot make up data, you can't invent data, you have to use the actual scores, and when we have missing values, then we don't know the scores. And so people are reluctant oftentimes to use imputation methods because they think that then that is like cheating or making up data or fabricating data. And so a lot of people don't like that, and they think that it is not a good approach. And so I want to shed more light on this issue here in this video. Is it really a bad idea? Is it cheating when you impute missing scores, or can you feel good about it? Are there even advantages to doing that? And so first of all, the answer is no. It doesn't generally mean that you are cheating or doing something bad when you impute missing values. Now, that being said, there are differences between imputation methods, and there are certain imputation methods that really are bad and that you should not use, that should be avoided. In general, the methods for imputing missing scores that you should avoid are so-called single imputation methods. Single imputation methods take whatever score you feel is reasonable to replace missing scores and put them in. For example, the mean. So that's a very common method of imputation with a single score, is to use the mean of the sample or the intra-individual mean or something like that in a longitudinal study to impute missing scores, or the median. And that really is problematic because, or there are several reasons actually why this is problematic. One is that when you impute the mean as if this were the actual score, then you reduce the variance of the sample automatically. So you cause bias in the estimation of variances, especially if you have many missing scores. And then also you don't take into account the uncertainty that comes with the mean. The mean is a sample estimate, which means it has uncertainty attached to it, estimation error, sampling error, and that is reflected in the standard error of the mean. Now you're not taking into account the standard error of the mean when you impute the mean into your data set. So you basically pretend that you know exactly what the missing score is, and there's no so to say variance or error estimate that is attached to that. And that is also problematic, especially for statistical inference. So when you want to conduct tests of statistical significance, then those can be incorrect. And so similar problems occur with approaches such as last observation carried forward, where you impute with the previous score in longitudinal data, for example. So that is also a bad idea. So generally, these single imputation techniques really aren't a good idea, even though intuitively it seems like the mean would be a reasonable estimate, but it causes all kinds of problems and it should be avoided. However, that does not mean that imputing missing scores is generally bad. You just have to do it right. And so one method that is mathematically and statistically sound is multiple imputation. Multiple imputation works very well when you have missing completely at random data or missing at random data, which we often have. So oftentimes we have at least missing at random data, which means there is information about why people have missing scores in your data set. There are other variables that are correlated with missingness. And so then we can reasonably assume oftentimes that the data are missing at random or even missing completely at random or a combination of those two. And so under these missing data mechanisms of missing at random or missing completely at random, it is absolutely reasonable, and not just reasonable, but it is a good idea to use multiple imputation to address missingness. Why is it a good idea? Because if you delete cases, like for example, if you use listwise deletion, then you're actually making a more restrictive assumption, a less realistic assumption about the missing data mechanism. Namely, you would be assuming missing completely at random data. Otherwise, listwise deletion would not be reasonable, and that is something that is less likely to hold in practice than missing at random, which is a less restrictive missing data mechanism. And multiple imputation only requires missing at random data as the mechanism, not missing completely at random. So it's less restrictive. It also works when you have missing at random data, whereas listwise deletion only works when you have missing completely at random data, and otherwise would potentially introduce bias. Also, listwise deletion reduces your statistical power because you're throwing away a lot of the information from the partial cases, from the cases with partial data, where they would contribute some information to your analysis, and you're throwing that away and you're only using complete cases. So imputation, multiple imputation, is often a good idea. And why is it better than single imputation? Because multiple imputation doesn't only use a single score, so like the mean, to replace missing values, but instead it estimates multiple different scores. So you, for example, run 50 imputations or 100 imputations, and that then results in there being an estimate of the between imputation variance in the imputed values. So you can then estimate and get a sense for what the uncertainty is that comes with the missing data. And you can take that into account in your statistical inference. So between imputations, there will be variance in the estimated scores. They will not all be the same in all imputations, and that between imputation variance is taken into account when you use multiple imputation. That's why it's called multiple imputation, because you're not creating just a single imputed data set, but multiple imputed data sets, and then you fit your statistical analysis model to each of these imputed data sets, and you aggregate the results across the 50 or 100 imputed data sets. And many software programs actually now automate the process for you. For example, Mplus, which I often discuss here on this channel, is a software program that makes multiple imputation very convenient, that already gives you a summary of the results where it's already aggregated across those imputed data sets. It gives you an estimate of the between imputation variance, so you can see how much of the uncertainty comes from the missing values. And so that's very convenient and easy to use. It can be applied to not just structural equation modeling, but also to simpler techniques such as regression analysis or ANOVA or a t-test, or correlation analysis. So it's easy to use in software for structural equation modeling. Now, again, this means, in summary, imputing missing scores is not per se bad. It doesn't mean cheating. You just have to do it right. And one way to do it right is by using multiple imputation, not single imputation techniques. Those should be avoided. But multiple imputation is a good thing to reduce bias, to increase your statistical power and take all the available data into account, because you don't want to throw away information that you spend time and money collecting. And that is something that can be used with multiple imputation. An alternative to multiple imputation that is based on the same mathematical theory or an equivalent mathematical theory is called full information maximum likelihood estimation, which can also be applied to many techniques, including regression analysis, ANOVA, t-test, structural equation modeling, and others. Is something that's even simpler and where you don't have to impute missing values. If you feel uncomfortable and you feel like I don't want to impute missing scores, you can use full information maximum likelihood, which is the asymptotically equivalent to multiple imputation without imputing missing values. It simply uses all the information from your data, including cases that have partial data, and gives you parameter estimates that are based on the full sample, the full information in your data. And that's something that's even more convenient to use from a user perspective. It's more user-friendly even than multiple imputation. It's implemented in many software programs for structural equation modeling, including Mplus, Lavan, Amos, other programs, and it's very easy to use. It's even the default in many programs, so you don't even have to tell the program, please use full information maximum likelihood. It'll do it automatically for you. I hope you found this video useful to learn more about proper missing data handling. If you did, then please subscribe to this channel. Don't forget to check out the description for additional resources, including a missing data analysis with Mplus course that I offer through QuantFish, and I'll see you next time.